All right, we are going to be doing target B today, and target B starts on page 9. We're going to jump around a little bit. You're going to skip an activity that I would have had you do if we were in person. And target B is basically two concepts put together to make one target. And we're going to do both concepts today. We're going to take notes on them today and we'll practice tomorrow. First thing we have is complementary angles. This is a definition. Complementary angles are two angles that add up to be 90 degrees. And we'll talk about why they have to be less than 90 in a second. Two angles where both angles are less than 90 degrees that add up to 90. Because if we go right to this picture right here, we know that all triangles add up to 180 degrees. And another thing that you also know is that a right angle, the value of a right angle is 90 degrees. So if I take 180 and subtract 90, I know that the rest of this triangle needs to equal 90 degrees. So what I know is that angle Z, whatever angle Z is, plus angle X needs to make up that missing 90 degrees. All triangles add up to 180 degrees. And this right angle alone, it takes up 90 of those degrees. So I have 90 missing degrees that need to be made up from my angle Z and my angle X. No matter what they are, they need to make up that 90 degrees. So what is the value of angle X plus angle Z? They need to equal 90 degrees. So that's what we went over. And then using this picture though, I'm going to give this triangle some numbers so that it makes sense what we're going to do with the rest of the page. I'm going to make this side 13, this side 12, and this side 5. So we can do trigonometric ratios. So make sure you label that. That's not already labeled for you. And this problem says to make a point we're going to discover by ourselves, use trig ratios to write xy, which xy is up here. I'm sorry, this should say 5, not 15. That should say 5. xy is 5, and zx is 13 in two different ways. So I want to put, how can I use trig ratios to write 5 over 13? And trig ratios are sine, cosine, and tangent. And so I'm just going to start with marking one of the angles and seeing what I can do there. So if I start with angle Z, the way I can make 5 over 13, well, I can use sine. Sine of Z is equal to 5 over 13. SOHCAHTOA, S over O over H. 5 is my opposite, H is my hypotenuse. All right. And I want to do two different ways. So that's one way. So I picked one angle and saw which trig function I can use for those two sides. Now I'm going to go pick my other angle. The other angle I'm going to use is angle X. And so to use 5 and 13 with angle X, I can use cosine. Cosine of X is equal to 5 over 13. And then we're not going to do it with the other ones for time constraint. But what conclusions can be made about the sine of Z, which I started with, and the cosine of X? Well, I hope you agree with me, but they're equal. Sine of Z was equal to 5 over 13, and the cosine of X was equal to the sine over 13. 5 over 13. So sine of Z is equal to cosine of X. What this means, this main point, one of the two main points for target B is the sine of one angle in your triangle. The sine of one angle in your triangle, sine of Z, is going to equal the cosine of the other angle in your triangle. Remember, we don't use our right angle here. The right angle only helps me identify what the hypotenuse is. But the sine of Z is going to equal the cosine of X. Sine of Z is going to equal the cosine of X. Think the opposite. The opposite of sine, think cosine, and the opposite of Z, think the other. Sine of Z is equal to the cosine of X. Similarly, I could say the cosine of Z, well, it's equal to its opposites. Two things need to change. The cosine needs to change to sine, and the angle needs to change to the other angle, opposites. Cosine of Z is equal to sine of X. Make sure you understand that. I'm going to do the next problem, not in a video, but you can check my work in the next problem to see these again. So check that out. And on page 10, check